How can you tell the difference between a physical change and a chemical change? This is our physical or chemical change lab. Chemistry is the study of matter and the changes that matter undergoes. Some of those changes are physical and some of those changes are chemical. What is the difference between the two of them? Take the sheet of paper. If I were to put this paper through a physical change, that is a change in the state of that matter, I could do something like crumple it up or maybe even take little pieces of it and shred it. But as you can see, these are physical changes because the paper that I have torn up has exactly the same chemical composition as the paper it came from. Now, let's think about a chemical change. A chemical change requires a rearrangement of atoms. Now, when you think about the rearrangement of atoms in matter, you cannot rearrange unless you're actually breaking some bonds and making some new ones. Let's look at what a chemical change looks like. I'm going to take a little lighter and I'm going to start burning my paper. Let's burn it some more. Now let's look at what happened to this paper. We started out with paper that looked like this, and now we have ash. That ash will never again be this paper. They are not only physically distinct, they are also chemically distinct. That is the difference between a physical and chemical change. In today's lab, we are going to look at the difference between a physical change and a chemical change. And I will tell you one thing that's very important. Sometimes chemical changes are not very easy to see. And that is the reason why we're going to be running this lab using sensors. Are you ready? Let's get started. Our setup today is very simple. We begin with safety. That means you must be already wearing your safety goggles. Here's what we have on our table for our lab today. We have 4 solutions. Nobody knows what's in them. They are unknown. Solution A has a color. It is blue. Solution B is yellow. Solution C is clear. And solution D is also clear. There's about 25 milliliters of material in each one of these beakers. We also have 2 additional beakers. One that is labeled AB, tells you a little bit of what we're going to be doing with that. And the other one is labeled CD. And if you look at what we have for our sensors today, we have a wireless temperature sensor, we have a wireless conductivity sensor, and we have a wireless pH sensor. All 3 sensors have already been paired by Bluetooth with our Sparkvue software. We also have, at least this is something that I find very handy, a little holder so that I can put 2 sensors into one little bracket just to make things a little bit easier for me. I love having a large tub of distilled water as my wash bucket, especially in labs where we're using 3 different sensors. Or you can choose to use your typical wash bottle. So I have this, I will show you why I have this little dropper with me. And of course, it's always handy dandy to have a little box of Kim wipes with you. These are all of the materials we're going to be needing for today's lab. Our lab begins with setting up Sparkvue. There is a configuration file on Sparkvue. Once you have paired your instrumentation, you can go and look at an open PASCO experiment, and under Essential Chemistry, just look for Lab 3C. It is already set up for you to run. And as you can see on the screen, it is going to do a number readout, and it has both temperature, conductivity, as well as pH, all set to run. So I think we're going to begin right now. I have 2 of my sensors being held together in the bracket, and I will work with the 3rd sensor, and we're going to take all of these parameter readings for each of our solutions today. Let's start with the first one. I'm going to stop it right here. Solution A, and I will write this information down, as you should be too. I will write this information down. My temperature is 23.5. My conductivity is 24. And my pH is 8.1. Now we're going to rinse our probes. And always blot the probes pretty well before you do your next determination. I will stop this right here, and I will write down, and you guys are noting the colors of these solutions, I take it. We have a temperature of 23.2, conductivity of 3, and a pH of 8.4. Back to our rinse. We blot again. Now let's go to solution C. Whoa, that looks really different. So solution C has a temperature of 23.0. I'm going to stop this right here. And I'm freezing this at 19,008 for our conductivity. And our pH is 12.9. Rinse that out. Blot it. And let's go to solution 4. Oh my goodness. Solution 4, just let it stabilize just a little bit more, and I am going to freeze this so that solution 4 has a temperature of 23.3, a conductivity of 21,845, and a pH of 1.5. I know you're guessing what we have here. It's okay. We're going to work on this a little bit more. All right. So now we have measurements of temperature, conductivity, and pH of each of our solutions. Let's see what happens when we mix them. Are we going to have a physical change? Are we going to have a chemical change? So I want you to make sure that not only are you watching our Sparkvue screen, that you're also looking at the data you have already collected on each of our solutions. So let's get started. I have a beaker in which I will mix solution A and solution B. Start that. So I've mixed solution A and solution B, and you can probably see it. The color has changed. It has changed to green, so please make sure you're noting that. And now the temperature is let me just stop this right here. 23.6. Our conductivity is 11. And our pH is 7.9. It's pretty close to 8. Let's see what happens if we mix C and D. We're going to start this. We have solution D in this beaker, and we're going to add solution C to it. Are you guys watching what's happening to the temperature and the conductivity? What sort of changes are you noticing? Check out the temperature. Looks like it's gone up, hasn't it? Doesn't it? Let's turn this off. We are now locking at 24.2 for our temperature. We have a conductivity of 5,062, and we have a pH of 3.9. That's a huge change right there. In the next section, we're going to talk about what all this means and how we analyze this data. To analyze your data, I first would like to ask you to look at the data you just collected from this lab. Look at all the parameters for each of the individual solutions, and then look what happened to those parameters when you mix them. So in your solutions, I want you to look at what AB and CD look like compared to the original solutions A and B and solutions C and D. As you look at those numbers, I want you to think about which combination AB or CD gave very different numbers in terms of their conductivity, temperature, as well as pH. These are important things to understand. Why? If you have a physical change, you will not likely find a whole lot of difference between a combination of one solution and another. That is very different when you have a chemical change that requires the breaking and rearranging of bonds. Now, it's your turn.